about the solid fuel coal. Solid fuel coal. So solid fuel coal, it is also one of the fossil fuel, and we Indians are mostly dependent on this coal because our thermal production unit totally runs with coal. If just 2 years back the data was 80% we were dependent on coal, and now we are dependent only 50%, 52%. Specific data. So that means we have progressed a lot in last 2 years. Alternative energy resources that we are talking about here and there, that is actually coming in the market, and everywhere government is also giving subsidy so that solar panel can be installed into every household. So do you know that every kilowatt of the solar panel, if you put at your rooftop, you get 18,000 subsidy from government. There is a program already going on. Everyone can utilize this facility. You have to register, you have to actually implement, and you will get 18,000 subsidy per kilowatt. Now depending on your house, size of your house. So why I am telling this, actually I have applied into our rooftop, for our building rooftop. So at the building rooftop, if you apply for 1 kilowatt, it will be 18,000. If you go for 10 kilowatt, so I can tell you the data about 10 kilowatt, because 10 kilowatt costing coming 5 lakh, and government is giving 1,80,000 because 18,000 per kilowatt. So it is 1,80,000. So rest 3,20,000 we have to spend. Okay. So that way the system is there. And already so many people are implementing, and after this you will find every rooftop is filled up with solar panels. That means we have progressed a lot, but still we are 52%. So you have to know about coal. That is the what I am telling. That is your reason. That is the reason, or that is the concept why you are learning about coal. Okay, because coal is not absolute yet, because we are still dependent on coal. 52% is also not less. 52% is also not less. So quite good amount of coal we are utilizing. So what is coal? Fossil fuel. It has called carbon, hydrogen, nitrogen, oxygen. These are the different elements present in this coal. Now we are analyzing this coal. Classification of coal. First of all, classification means types of coal. Different types of coal. What are the different types of coal? You know that already. Peat, lignite, bituminous, anthracite, subbituminous. These are the different names. Okay, so we sometimes call this rank of coal. Rank means the quality. Like joint tenants rank. Rank gives the quality. So rank of coal means it is talking about the quality of the coal. Now high rank coal and low rank coal. High rank coal means the carbon percent is good. Calorific value will be higher. Both are parallel. If carbon percent is high, that means calorific value will be high, because carbon is the main component that is combustible. The other things what is there, oxygen, nitrogen, it is not combustible. So what combustible part there is carbon, and that's why good amount of carbon should be there into coal. High percentage of carbon should be there. Now if you arrange peat, lignite, bituminous, anthracite in this order, your percentage of carbon and the calorific value are increasing. Okay? But one more thing to know, that in the market you will not get in the name anthracite coal, bituminous coal like that. It is available in the different grades, gradation. A1, A2, B1, B2, C1, C2, D1, D2, E1, E2. Why so many ABCD grade? ABCD is just short form. From that people will understand that is what is about the quality, and accordingly the price is settled. A1, A2 mostly used into your coking coal, for coking purpose. Bitumen highly rich with, we never use pure, always mixed. Okay, like bituminous is mixed with sometimes subbituminous. Lignite can be mixed with something else. So different about this mixing is there. Accordingly, these grades are there. And anthracite A1, A2, both are anthracite. Two different quality of anthracite, A1 and A2. Both are anthracite. But we are not calling it anthracite. We call it A1, A2 grade, and that is used into coking, for coking purpose, for making coke, and that coke will be used for steel plant. high quality the coke will be required for steel plant. That is A1, A2 grade. Where temperature should be quite high, it should raise more than 1000 degree. Then we need anthracite. If you need less temperature, then you can go for B1, B2 grade, C1, C2 grade, different other grades. Always not necessary that A1, A2 grade will be the best for every purpose. No, it is not. It is best for only the steel making purpose. Steel making you have to go for A1, A2. Other purpose B1, B2, C1, C2, D1, D2 according to your requirement. Suppose you are making some incense stick, mane dhoop, okay, agarbatti, that one. So there the temperature should be quite low, should not go more than 100. So quality of coal should be quite down. So in that case D1, D2 will be good. Not at all A1, A2, B1, B2, C1, C2. D1, D2 will be good. Because temperature should not shoot up more than 100. Everything will burn, will be charred. Okay, that's why. Temperature control. And the rank, rank is peat bituminous, peat lignite bituminous anthracite. Just write side by side. Peat, okay, lignite, bituminous, anthracite. Okay, so in left to right, if you move, peat, lignite, bituminous, anthracite. Left to right, if you move, percentage of carbon and calorific value both are increasing. So that is called, this phenomena is called ranking of coal, rank of coal. So you are going from lower rank to higher rank. And there is a term called fuel switching. Two different fuels are mixed together, blended together. That is called fuel switching. That has got a purpose. So that we can make different gradation of coal. A1, A2, B1, B2, C1, C2, D1, D2. These are the gradation of coal. Not always purely anthracite, bituminous. That way we are using. But in the market you will get in this type of name. Because these are all mixed. Fuel switching done. Why? Why mixing is done? Well, to get the particular desired quality. Where for coal also we need particular quality. Any coal anywhere will not do. So specific quality required. So for that quality purpose, what you are getting from the mine is not good enough. You are mixing, grinding, making powdery, and accordingly we are using after that. Okay, some processing is there. So this processing, after processing, what we get different type of gradation. Okay, and what is rank? Rank is pure quality, pure. That is your anthracite, bituminous, lignite. So these are rank. But after you mix it, you get different gradation, which is not rank of coal, but your gradation of coal, A1, A2, B1, B2. These are commercial gradations. Got it? So from left to right in this range, what you have written already, from left to right you are getting good higher rank. Okay, higher calorific value, higher rank. But that does not mean it is suitable for every purpose. So for the practical purpose, we have to always mix it thoroughly. Achha, one practical example. When you burn coal, lot of sulfur dioxide gas is also produced. That is undesirable. Sulfur dioxide is bad for everything, bad for health, bad for environment, society, everywhere is bad. So, sulfur percentage should be low. But how do you do that? When you take out coal from the mine, it will contain sulfur at least 5%. So, you cannot just remove coal sulfur from coal is difficult. So, that's why sometimes what people do practically, take two different quality of coal and blend together, reduce the percentage of sulfur. Because some sulfur available in some area which is having less sulfur, some other area you have more sulfur. But you cannot discard that high sulfur content coal. Rather than if you mix it, percentage goes down. And you have some level that below that sulfur content, if it is there, it is suitable, no problem. So suppose below 3% is suitable. You have to make it from 5% to 3%. So very low sulfur coal and high sulfur coal, if you blend together, you are getting below 3%. So that is the way we are doing. People are doing. Okay, let's go ahead. So this is ranking. Peat, lignite, bituminous, anthracite, different these ranges of coal are there. So that is going upward, going higher means quality better. Quality better in the sense calorific value high. That is the main thing. Because coal, what do we expect? Only calorie. So calorific value is high. So that's why we are calling it better ranking, higher ranking. Then coming to analysis, specifically coming to analysis. So what is analysis of coal? Hey, mobile ta bondo koro. So two types of analysis there: proximate and ultimate analysis. Proximate means, what is the term? Proximate means close, closeness. That is proximate. So proximate analysis means close analysis. So what is the meaning of close analysis? We are getting certain parameter out of what are the parameter? One is moisture content. The coal, how much water content there in that coal, bhije na shukno actually, dry or wet. So that is called the moisture content. So moisture content is one of the parameter we are getting here, proximate analysis. Second parameter, volatile organic compound content. How much volatile matter content? Volatile matter means lot of things are there volatile. Phosphorus there, it is volatile. If you apply heat, phosphorus will become what? P2O5. It will burn. No? So phosphorus will burn and produce certain gas. At a high temperature, this P2O5 is gas, so it goes out. Sulfur, it will form sulfur dioxide gas, it goes out. So these are all volatile. So in general, not generally volatile, but when you are applying heat, then it is becoming volatile. And the coal becoming porous. Yeah, porous, because inside it is trapped different type of other compounds, so, other minerals or elements. When you apply heat, these are burnt, forming gas and going out. So when it is going out from the coal becoming porous, because it is getting filled up by air. Then the gas goes out, so it cannot be empty or vacuum. So inside air seeps in, and you get porous this texture of the coal. So this is called volatile matter. Some materials there in the coal, it is called volatile matter. When you burn only, this thing comes out. That is called volatile matter. So is it good or bad? Volatile matter. Volatile matter also gives some calorific value, because these are combustible material. Sulfur is also combustible material, giving some calorific value. So in that sense, you can say it is good. But on the other sense, there is a problem also. Flame is forming. When there is a volatile matter, it will give you flame. A long flame always bad, because it will go out of the furnace. Very difficult to control the flame. Flame goes out of the furnace. Long flame comes. That's why it is giving trouble, and it is not advantageous. It is bad. So good and bad is always there. Pros and cons. It is called pros and cons. So pros are there, cons are also there. Positive benefit and problem, negative, both are there. So here, volatile matter content is another parameter. You have to always analyze this quality of coal, where there is a volatile matter content, high or low. If it is high, you cannot use it into normal furnace. You can use it for making coal gas, because gas content high. So if you apply that type of coal to produce coal gas, you get more amount of coal gas. So volatile matter high means it is suitable for making coal gas. Sometimes we are making coal gas from coal. So there it is good. Purpose will be changed. But if the volatile matter content low, it is suitable for furnace. Furnace means thermal power plant. Furnace. Okay, that is the furnace. Achha. So one is told you moisture content. Second one is volatile matter. Third one is ash content. Ash content means after burning the remaining solid material which is not combustible. So what is that actually? Oxides, different metal oxides. So when you burn the coal, the metals are getting burnt also, producing oxide. Metal oxide, sodium oxide, potassium oxide, aluminium oxide means alumina, or iron oxide, different levels of zinc oxide, anything can be there. All these different type of oxide. What is the color of ash after burning the coal? Grey, na? This grey is because of most of the time what you have is calcium oxide, magnesium oxide, alumina. These are all off-white type of color. So when it is blended all together, zinc oxide, these are all colorless. Colorless or some off-white type of color. So that's why the blend is, you are getting some off-white or grey type of color. That is a lot of things that they are blended together. But mostly oxide, they are all oxides. Different type of oxides. Okay, calcium oxide, magnesium oxide, zinc oxide is a major. Major is calcium, magnesium oxide. These two are very common. And that's why the color is like that. So it is ash. And that is there always. Whenever you burn coal, you get ash. But high ash content is not good. Why not? Because high ash content means actually you are getting less energy, and calorific value will be less. Why? Because the more amount of ash means the actually percentage of carbon, combustible carbon is less. So you are getting low calorific value. So that's why it is not good. So anyway, so this plus and minus will be there, and there is the last one. It's called fixed carbon. Fixed carbon. So what is fixed carbon? 100 minus percentage of all the other things. Means all the other things means ash content, volatile matter content. If you deduct all this, what will be left behind is called fixed carbon, and the higher fixed carbon is good. So this type of analysis, what I told, just brief idea, maybe we will go into detail. So this is a brief idea. This is called proximate analysis, close analysis. Next is ultimate analysis. Ultimate analysis is also called elemental analysis. That means what are the different elements present? What are the elements present? What do you think? Cole, what are the elements? Carbon. Carbon is main. Then hydrogen, oxygen, nitrogen, some sulfur. Isn't it? Yeah. Achha. Others are traces. That's why we are ignoring. Mostly what we are analyzing, carbon, hydrogen, nitrogen and sulfur. And others are all ignorable. You don't care about that because very small. Anyway, so this type of analysis is called ultimate analysis. How much carbon percentage, how much hydrogen percentage. If you analyze actually by some method, that is called ultimate analysis. Now let's go to proximate analysis in detail. Some brief overview I told you. So you have to get some brief overview, summary, otherwise you don't understand what you are doing. Now this proximate analysis, let's go ahead. You have just see the picture there, looking like a small almirah. That is a furnace. It is called muffle furnace. MUFFLE, muffle. MUFFLE is called muffle furnace. So this muffle furnace, what you have, this picture I inserted so that you can understand what is the design or what is the type. It's just like a hot air oven, air fryer, hot air oven. We have in the lab also there is a oven like this. But this muffle furnace is something different. Looking like this, inside there is a small chamber and temperature goes very high. That is the main function. Hot air oven temperature hardly how much? 200, 300, 400, not more than that. That is called hot air oven. For drying that glass apparatus we are using that. It is called hot air oven. Maybe you have seen it into our lab. There is a hot air oven. The chamber like just looking like this. So there you just keep the wet glass apparatus and it gets dried up. After half an hour if you take out you will find it will be dry. So for drying purpose we are using it. Okay, that is hot air oven. But this muffle furnace, temperature you can control. Start from room temperature. Starting from room temperature, you can go up to 1100, 1200 degree temperature. Different type of muffle furnace is available. Okay, different cost obviously. Now, first of all, the parameter we are measuring is called Kelvin. এখন কি এত লেটে আসে জানি কত বেজে গেছে জ্যাম ফ্যাম না আগে বেরোবে okay, so temperature around 100 if you keep for certain time then the coal will be dried up. So that we are using. We are taking a specific amount of coal, let it be 1 gram. But as the coal is usually lump. So taking dhela. So this lump, if you taking the weight, measuring the weight is actually difficult because if you put in the pan, suddenly that weight will be jump high. Not powder, na? So weighing will be difficult. So that's why it is not specifically 1 gram but very close to 1 gram is kept. This you will get granules, na? Not very fine powder. If you do it grinding also, you get granules of coal. So while weighing, we are taking around 1 gram, maybe 1.1 gram or 0.97 gram, whatever comes, we accept that. Okay, that is W1. Practical experiment you are doing. Let it be W1. Just we are discussing in the lab now, W1, W2. So let it be W1. Which one? The coal quantity. 1 gram. Take it. Exact not 1 gram. That's what I'm telling W1. It may be 1.1 gram, it may be 0.97 gram, from 92 gram. Like that. Achha. You have taken 1 gram into certain container. It is called crucible. And the crucible is made of nickel or porcelain. Porcelain or nickel. Material is porcelain or nickel. So in that you just keep it and put into the oven. Temperature is kept around, it is written here, 105, 110 degree. Okay. So it is just kept in the 110, 105, 110 degree temperature. Slight fluctuation will be always there. Plus minus 5 degrees allowed. In that temperature the coal is kept for some certain time. Let it be 10-15 minutes. Then take it out. Let it be cold. And after chilling, you just take the weight. How much the drop of that weight, loss of weight, that you are measuring. That means initial weight and final weight, the difference. So, the percentage of moisture will be loss in weight divided by weight of coal taken into 100. And one precaution. After this first trial, you have to keep in the oven one more time for 5-10 minutes. Take out and see whether the weight change is happening or not. If constant weight, then only you can consider that data. Because if it is not completed, you have to give some more time. Always not possible that with same time it is done, because the coal sample may be sometimes more weight, sometimes less dry, comparatively dry. So if it is comparatively dry, it will take less time to dry. If it is comparatively wet, it will take more time. So that's why you have to take a second trial. First trial you have taken the weight, fine, everything fine. After that, put it in the oven once more and verify the weight once more. If the weight is not changing, that means your experiment is done. So this is called the moisture content. So this is the formula, percentage of moisture. Done. With the same instrument. Instrument is not different. Okay, this is the same instrument. We can again go ahead, go temperature, higher temperature. Higher temperature we are giving. So, by the way, let's finish this proximate analysis. What are the significance? Significance of moisture. Significance means again benefit or problem. So, if you have a high moisture content, is it good or bad? It is bad because it will reduce the calorific value. Moisture means water. It goes out, it will collect the latent heat. So your calorific value will be down. That's why in the rainy season we are spending more amount of coal and more money to get same amount of electricity. We means actually electric supply company, because the electric supply company taking bill equal throughout the season from us. But maybe they are getting more benefit in winter season compared to the rainy season. In the rainy season they are not getting that profit, less profit they are getting. So throughout the year they are taking the same value, so it is getting managed. Got it? So what is happening? So if the coal is comparatively wet, more amount of coal you have to burn to get the same amount of energy. Quite obvious, because it is collecting the latent heat and getting evaporated out. More and more amount of heat is lost. Okay, wasted, waste heat. Heat is getting wasted because it is utilized to produce steam out of moisture. Okay. So it is not good. Achha, if it is totally dry, is it good? No, then also there is a problem. If it is totally dry, it will produce too much of fly ash. Chai udbe. It will be too much of fly ash and people nearby will be all affected. Health will be affected. Nake dhukbe to, dhulo. The dhulo means not ordinary, it is fly ash. It is coming out from the chimney. So it is bad, very bad for health. It will give different type of breathing trouble. Okay. So that's why zero moisture is also not good. Some amount of moisture should be there. Hey, কি হলো মোবাইল টিপছ না তো? হ্যাঁ কি হলো এটা এর ব্যাড হ্যাবিট, দ্বিতীয়বার একদম আর বলবো না, একদম বাবাকে ফোন করবো। So now the third one, volatile matter. Third one is second one. Moisture to already just moisture I have completed. So next go to next one, volatile matter. See the temperature here, 925 plus minus 20 degrees centigrade. But this is from only for 7 minutes. Should not give that much of high temperature for a long time, because if you give long time it will burn completely. Nothing, no data will get. You are analyzing. Okay. Temperature should be high, otherwise the volatile matter will not come out. You are distilling it. Distilling the coal, that is the thing. So distilling coal means quite high temperature. But one thing, we are not giving sufficient air. It is closed container. So that's why burning will be to some extent controlled. Okay. We can control to some extent because we are not giving air. It is closed container. Achha, what is the container? This crucible, it is written crucible, fine. The same crucible, if you continue, it will be convenient for us. Just take a weight and again you put into the furnace, just increase the temperature. Yes. So it will be very easy. But there is another type of container available, particularly for this purpose, volatile matter content, and that is called VM crucible. That is separate crucible. Crucible design is different. For other purpose, the crucible is like a small pot, bati, small pot type. But for this volatile matter, it is a cylindrical one. Okay, cylindrical. Now, actually with a lid, small mouth with a lid, so that air cannot penetrate and it will not burn. Otherwise, coal can be burned in presence of oxygen. So, distillation is always done. Whenever you go for coal distillation, distillation should be done always in absence of air or very limited air. That is the purpose. Instead of that open pot, if you take some closed container, that can be again nickel porcelain, but with a lid with it, so that air cannot go in and it cannot burn the coal. At least to some extent you are controlling. But the lid is not very tightly fitted. Okay, lid is like that gas can go out. So it should be perforated lid. Perforated lid. Futo ache. So gas can go out, but air cannot penetrate. Because from the same pathway, gas coming out and gas going in, not possible. So as the gas is coming out with a high pressure, so obviously gas cannot penetrate there. So that way you are preventing the burning of coal. Without oxygen it cannot burn. Na? High temperature fine, but without oxygen it cannot burn. So you are controlling the supply of oxygen. So that is done. Only 7 minutes. That is also controlled. Time is also controlled. So after that again there is a weight loss. You have to measure the weight loss. From the weight loss you get percentage of volatile matter content in the coal. Quality. How much volatile matter content there, if you want to analyze, this is the way. High volatile matter, already I told you, high volatile matter it is good for making coal gas, but not good for furnace. Low volatile matter is good for furnace. That is the consequence or analysis, significance. Sometimes it may contribute to calorific value, this volatile matter, but it's controlling difficult, that's why we normally avoid. And one more thing, if the flame come out, it is hazardous. From the furnace, if the flame comes out, people in the surrounding cannot stay to do their job, because flame is quite dangerous. It is hazardous. That's why it should be always contained inside the furnace. So high volatile matter content is not good. We cannot make things sealed also. You have to supply air. So it is not sealed. Next, third one is ash. Ash content, how to do? Same furnace, everything, half an hour, 700 degrees centigrade is kept. Temperature comparatively less. So this one is, how much was temperature? 925. Now it is 700. Comparatively less temperature. But time is more. That means you are doing the burning completely, complete burning to get the ash content. Now percentage of ash will be weight of ash left by the weight of coal taken into 100. That is the giving the percentage of ash content. So high ash content is not good, that already you have discussed, but one thing I am not told you yet, high ash can melt. At a high temperature, ash can melt. And if it melts, there are always cuts and cracks in the furnace. There are cracks because you are continuously using it for a long period, heating is continuously done. There will be cracks in the wall of the furnace. Now the ash can melt and flow and it can go inside those cracks, fill up those gaps, and what is the problem? Two different material in the same place. One is the ash material, other one is the actually refractive material, that is the furnace is made without that. The furnace is made with some refractive material. Now there are cracks inside, and in this crack the ash is molten and this molten ash flow inside. Then what will happen? Then two different material, na? So thermal expansion coefficient of two different material will be different. It will create lot of stretch and the furnace will crack. Furnace will burst. So life of the furnace will be reduced. So that means ash content is actually dangerous for the furnace. So lower the ash content is better. You cannot totally make it zero, but ash content is should be low. So these two things, ash is reducing calorific value content. You are giving more amount of money, spending more money for the transportation cost, because you are carrying the coal, ash is also there. Okay, so you are actually spending more money for less amount of energy. So the cost will rise, cost of everything will rise. And another problem, I told you, molten ash can damage the furnace. These two things. Proximate analysis, fixed carbon content, that is always good because fixed carbon is the thing that we need. That is the thing we need. Carbon content should be good. High carbon content means good amount of good calorific value, high calorific value. Okay, so it is better. So these are the things, these are the parameters there under proximate analysis. Moisture content, volatile matter, ash content and fixed carbon. These four things. I think enough discussed, so I skip this video. There is a video actually, just this is doing this. So I vividly discussed how it is done, so no further required. So to save time I skipped it. Now ultimate analysis. Ultimate analysis, we are analyzing the different elements, elemental analysis. It is also called elemental analysis. So have you heard about Dumas method? Organic compound, Dumas method analysis in the 11, 12 standard, 12 standard I think. Dumas method, there is a method just like this, the same method. This is Dumas method, the same method. For carbon and hydrogen content, you are using this method. Here you have some sample, maybe coal, maybe organic compound, any organic compound. You want to analyze the carbon percentage and hydrogen percentage, you can use it. So there is a long hard glass tube. Long hard glass tube. You can make it. Glass factory, if you give order, they will make it, and this is available. Now there is a pure dry hydrogen gas going inside. Good. ওটা তো ওটা তো ওই ডিওআইটা দিয়েছি না, ওইখানে ক্লিক করলে তো ঢুকে যাচ্ছে ফাইলটায়, পুরো ফাইলটাই আপলোডেড পুরো। মেলে দিয়েছি। আচ্ছা, ultimate analysis. Let's start the ultimate analysis. Carbon and hydrogen percentage. So Dumas method. This is a long tube, hard glass tube. Hard glass, why? Because we are applying heat, direct flame. So it should be a very hard glass. Like German Scott Duran company, they are making this type of very good materials. Scott Duran company. Scott Duran. They are making hard glass tubes, hard glass any material, laboratory glasswares. Okay. So there is a hydrogen gas, pure hydrogen, oxygen, pure dry oxygen gas passing through, and there is a flame. Okay, so flame here, Bunsen burner. You can see the Bunsen burner. Now inside there is a crucible container. Why crucible always? It can withstand good amount of heat. Otherwise things will break. So this crucible is a hard material. It is a porcelain crucible normally, or nickel crucible. So the coal sample is kept in that. Here is platinum board taken. Okay, fine. Crucible also will do. Platinum board is taken. Fine. So this heating is done. So if you heat and supply oxygen, what will happen? It will burn. Simply we are burning it, but specific quantity, because we are analyzing. So maybe 1 gram coal, 1 gram coal sample we are just burning, and burning is control environment so that you can analyze. So that's why in the control some chamber, not in open air. Burning you are doing, but not in open air, but in control chamber. Everything sealed, so that you can analyze. In open air you cannot analyze, na? Sealed chamber you can analyze. So here burning is done. So what will be produced? Coal burning, carbon dioxide, water vapor. These two things are measured, right? Ash will be remaining behind, but what will be going out or flowing out? One is the two gas meter. One is carbon dioxide gas, and there is H2, isn't it? H2 and carbon dioxide. So then it is passing through this CO pellets. It is also hot. CO pellet. Why CO pellet is given? Achha, some carbon monoxide also will be there here. Complete burning is not possible, na? Some carbon dioxide, some carbon monoxide. So you cannot keep carbon monoxide now, because it will be giving you wrong result. That's why complete combustion required. So how do you ensure complete combustion? Carbon monoxide produced will pass through the CO pellet, reducing CO into copper, and carbon monoxide will be converted to carbon dioxide. So what you get here is complete carbon dioxide, and moisture is moisture only, nothing will happen to that. So these, after that there are two different sides. It is called guard tubes, U tubes. It is called guard tube. Here in the first guard tube, calcium chloride, anhydrous calcium chloride is packed, and the gas mixture going through that. Moisture will be absorbed here. Anhydrous calcium chloride has a tendency to absorb moisture, so it will absorb the moisture, and the weight of this guard tube will be increased. And previously we have taken the weight of the guard tube. Now we will take the weight of the guard tube. From the difference we can understand how much moisture was measured or absorbed here. Moisture content we get here. Yes or no? Fine? Achha. Then second one for absorbing carbon dioxide. বলো কিছু বলে মনে হচ্ছে বলো
স্যার ওই যে কপার অক্সাইডটা আছে যখন ধরুন H2O গেল
কিউপ্রিক অক্সাইড
হাইড্রোক্সাইড হয়ে যাবে
না কিউপ্রিক অক্সাইডের মধ্যে তুমি একটা রিডিউসিং গ্যাস চালালে কপার হয়ে যাবে আর কার্বন ডাইঅক্সাইড অন্য অক্সাইড ও ইট ইজ অ্যাক্টিং অ্যাজ এ কার্বন মনোক্সাইড ইজ কল্ড carbon monoxide is what? It is a reducing agent, na? It will reduce copper oxide into copper and carbon dioxide. It is it is called carbon reduction process. Carbon dioxide, carbon monoxide, we are usually using in several area for making the metal manufacturing process, like iron oxide plus carbon monoxide. What do you get? Iron. So the same way we are doing it, but here not the purpose of making copper, but here our purpose is to get the analysis. We are doing the analysis. How much carbon dioxide? We want to get complete 100% carbon dioxide. Carbon monoxide should not be there, because if it is there, it will be lost in the environment and you will get wrong result. So that's why this is there. So here we get this first guard tube, we get the anhydrous calcium chloride, and the second guard tube we get the KOH. There is KOH there, so it will absorb the carbon dioxide. KOH will absorb the carbon dioxide, and here anhydrous calcium chloride will absorb the moisture. So from this what we get? H2 and CO2. We are analyzing how much H2O form, how much CO2 form, that we are analyzing. And if you know how much CO2, can't you calculate carbon into 12 by 44? Get the percentage. Possible? Achha. H2O, you make it into 2 divided by 18 into 100. Simple idea, no? So that is called Dumas method. It is not only for coal, from any organic compound we are doing this method, applying this method. For any organic compound analysis. How much carbon percentage, how much nitrogen percentage. Empirical formula, numerical kiya tha ki nahi? Empirical formula, numerical, based on this type of experiments. Data was given there and you are only doing the analysis, calculation. But here you see how the data was supplied. Here what you are observing is how the data was supplied for you numerical. Only you did the numerical, na? Now you see how the data was given to you for the calculation. After that you did the calculation. But this is the origin. This is the way people are measuring, and after that data is given. So this is the reactions and everything. Combustion that is happening in the platinum pot. This one, this platinum boat, it is called platinum boat. Achha, why platinum? You can use very long time. Once you make it, it is a very inert one, and you can use it very long time. That is the benefit, advantage. But cost is very high. Platinum is more than gold. More than gold. Okay, so combustion of carbon giving you carbon dioxide, and hydrogen is giving you water. So C and H percentage you get from here. Percentage of carbon you are getting into 12 by 44, as I told you, and for percentage of hydrogen into 2 divided by 18, and you are getting percentage. This is called Dumas method. Okay, only for carbon and hydrogen this method is applied. We have others also. This is the first step. Percentage of carbon and hydrogen. May I go ahead? It is there with you, or is it already given? Canvas, सब there. Okay, what is the purpose? Giving all the PowerPoint or all the materials together, so that before coming to class you just have a look. That is the purpose. That you are not doing, I know, but still that is the purpose. The significance of carbon and hydrogen is there. Achha, just tell me, carbon high is good or bad? Obviously good. Achha. Hydrogen, if hydrogen is high, is bad, because it will produce moisture. After burning, ultimately it will produce moisture, and that moisture will go out by collecting some heat from our produced heat. So actually we get less amount of heat in hand. We get less in hand because some is spent. Yes. Next is continue with the ultimate analysis. Next one is nitrogen. This parameter is nitrogen parameter. I already told you carbon, hydrogen, nitrogen, and sulfur. These 4 parameters. No, now this one is nitrogen. So for nitrogen, what method we are applying is called Zeldal. And what is Zeldal is in front of you. Picture is given. So this is Zeldal. So here this one is called RB, round bottom flask. Achha, why round bottom is always preferred? Round bottom is preferred. Cannot. Uniform heat. No, heat will be uniform. For round bottom only you get the uniform heating. That's why. So RB, there is a problem also. You cannot keep RB alone. Round bottom you cannot just keep here and there, because the bottom is round, so you cannot keep on some flat surface. Always you have to have some stand, something where you can keep it. That is the disadvantage. But still people are using it because this heating will be very much uniform throughout. Any other thing you take don't get that much of uniformity. That's why RB is preferred. In the laboratory always you will find RB, round bottom flask. And the top of the round bottom flask, this is a pipeline, and then you are getting a condenser. Okay. This whole apparatus is called Zeldal apparatus, and everything is glass made. This water is going in and cold water going in and hot water going out. That means what is the purpose? Cooling. This Zeldal, this condenser, purpose is cooling. So whatever reaction is done here, the vapor, anything that goes out, that is passing through this tube and ultimately going into some acid, unknown standard acid, some standard acid. Okay. Now what is there here? Some sample. It may be coal sample, it may be organic compound sample. This method is general. It is not only for coal, but we can apply it for coal also. So it takes some powdery sample. It should be as much as possible powdery. It should not be any lump or any granule there. Okay, because it will not dissolve otherwise. Coal, dissolving coal, so not so easy. No? Now you give concentrated sulfuric acid. Okay, and nitric acid mixture. So this type of things will be dissolved, or otherwise we are using here anyway. Okay. So first of all, see the method. First of all, we are taking some concentrated sulfuric acid with some K2SO4 as the catalyst. So concentrated sulfuric acid plus K2SO4 they are along with coal sample we are applying heat for dissolving it, just for dissolving it. After that we are giving sufficient excess NaOH into that, but be very careful. Hot sulfuric acid, we are adding NaOH into that, it may explode also. So we should be very slowly done, drop by drop, very carefully, because heat generated will be also very high and it is already hot. So first of all we are giving sulfuric acid and K2SO4, then digesting it for some time so that visibly clear solution will be there. Visibly clear means from outside you can see that the coal powder dissolved, otherwise you will find it here at the bottom. Okay, until and unless this powder from the bottom is totally dissolved, you can see it clearly from outside. Let it be dissolved first. After that you add NaOH. Okay, why NaOH? Because along with ammonia, this nitrogenous compound whatever they are in the coal, what will be fate of that? This ammonium compound will be nitrogenous compound will be converted to ammonium sulfate, NH4 whole to SO4. Sulfuric acid के साथ reaction किया ना, so it will give you NH4 whole to SO4. Whatever nitrogenous compound present in this coal dust is converted to ammonium sulfate, NH4 whole to SO4. Okay? না প্রবলেম নয় তো, ওটাতে করলাম, প্রবলেম তো বলছি না। You are taking coal sample, add sulfuric acid and K2SO4, apply strong heat quite good amount of time, so that all the coal can be dissolved completely, and from outside you can see this, that is already dissolved. Whenever dissolved, then you add excess NaOH, so that all sulfuric acid is neutralized and ammonia gas is produced. Ammonium sulfate tha na. Now whenever you are giving NaOH, then it will become alkali medium, and applying heat, this ammonium sulfate will break down, producing what? Na2SO4, sodium sulfate and ammonia gas. That ammonia gas coming out through the pipeline tube. This tube, through this tube, this ammonia gas is coming out. This ammonia gas, that is whatever coming out, is absorbed into some standard acid. That may be anything, HCl, H2SO4, no problem. Dilute NaOH, dilute H2SO4, but standard, maybe point on normal H2SO4, point on normal NaOH, HCl. Acid, it should be acid. Because ammonia is a base, it should react with acid. So you take some standard acid. Standard means known strength. Standard means standardized, means known strength. So in the some known strength acid, let it be dissolved. Gas could dissolve. After that, when everything is done, take out this and do the titration. So simple. Earlier you know the strength, now you do the titration and get the strength. From the difference you understand how much ammonia was dissolved. From that ammonia you get the nitrogen. Okay, could you understand this? Not very complicated. Some chemical reaction only. Simple chemical reaction. So we have learned in 9th and standard that reaction. Coal dissolve, ammonium sulfate form. Add NaOH, sodium sulfate and ammonia gas is formed. Let the ammonia gas go out and dissolve into some known strength standard acid, standardized acid. So strength of the acid will be reduced. Do the back titration. What is the remaining strength now? Original strength and remaining strength. From the difference you get how much ammonia is formed. Because volume of the acid is known, strength of the acid is known. After the absorption of ammonia, strength is reduced. How much reduced? That you can calculate by titration. After that titration, by calculation. So you get the how much ammonia was produced. From ammonia you get nitrogen. So how? 14 by 17 into 100. Nitrogen is 40, ammonia is 70, into 14 by 17 into 100 if you do. And always at the denominator will be amount of coal sample taken. Uniformly you will find that. Okay, at the bottom it will be always amount of coal sample taken. W1, W1. It can be 1, but exactly 1 not possible. No? It can be 1.1, 1.2. Why not exactly possible? Because it is lump or the granule. Never it is never very fine. Granules very fine powder. It is not like a talcum powder. It's not like talcum powder. It will be always these small granules or grains. So while taking the weight, that will make weighing difficult, na? So that's why it is not made very rigid. Okay, it is not very rigid. So around 1 gram will do. Or whatever you are taking at the denominator, na? So it is calculated with respect to that. So no problem. Exact not required. There is no error that way. If you take 1.1 gram, if you take 0.97 gram, no problem. Not getting error that way. So this is the calculation. আচ্ছা এখন ক্লাসে আছি পরে কথা বলছি ফোন করে ওটিপি ও
ওই যে 1.4টা বললেন না ওটা কি ক্যালকুলেশনের পরে 1.4 তো হবে না 14 বাই সামথিং হবে না রাইট ফোর সাইড
379211 379211 calculation you can make it simple. Instead of normality, you can use by 14 by 17 also.
14 by 17 is used.
Achha, next ultimate analysis, another parameter left, that is sulfur, and we end up there. Go for the EVS class, right? So this ultimate analysis, sulfur analysis, what we are doing, it is done into some chamber which is called Bohm calorimeter. Okay, and this sulfur converted to sulfate. It is determined from the washing obtained from the known mass of coal used in Bohm calorimeter for determination of calorific value. Achha, that means what? In the Bohm calorimeter, calorific value is measured. During that, the washing that is made, okay, that contains sulfur. So that sulfur is converted to sulfate. Sulfur, because you are heating, burning. Calorific value, how do you get? By burning only. So from that Bohm calorimeter washing that we get, practical experiment is done actually. In the Bohm calorimeter, what we do? We measure the calorific value. So during that measurement of calorific value, so any sulfur present in the coal is getting converted to sulfate. Why? Because sulfur will be burned into SO2. SO2 plus oxygen, SO3 plus water giving H2SO4 plus that sulfate, it will be always. যা ক্লাসে আছে পরে বেরিয়ে করছি হ্যাঁ বেরিয়ে করছি হ্যাঁ ঠিক আছে এখন ক্লাসটা কিন্তু 2 পিরিয়ড চলছে হ্যাঁ Okay, so first of all, coal burned. After coal burning, sulfur is there in the coal, that is converted to SO2 plus oxygen in the burning process itself, SO3 plus water producing H2SO. Fine? H2SO. Now, there are different things like calcium oxide, magnesium oxide, as we already discussed. No? So when you are burn coal, this oxides mixture is always common. CaO, MgO. So in place of whenever sulfuric acid produces EC2, it will obviously react with that, producing calcium sulfate, magnesium sulfate, or any type of sulfate, right? So ultimately what we get is sulfate. So in the leaching, after washing, the washing contains what? Sulfate, and it is quantitative. Whatever amount of sulfur was there, converted to sulfate now, because it was trapped, it is totally trapped, could not go out. You are not allowing anything to escape. So complete sealed arrangement. So what you get here? Sulfate. Sulfate acid could not go out. It is converted to sulfate. That is the procedure. So you get sulfate, leaching, the washing, that contains sulfate. Got it? This sulfate, what you can do, we take some barium chloride solution and add into this sulfate this wastewater. The water comes out, the leaching, the washing that we take, there we add barium chloride. What will happen? Before doing that, you should filter this. The solution should be filtered. And after that, the other particles if they are, so filter it, clean. And after the washing that we get, neat the washing material, there you add barium chloride. Immediately there will be precipitate of barium sulfate. Then you take, filter it, get the weight of the filter paper should be taken beforehand. Now after filtering you make it dry and then take the weight. Deduct the weight of filter paper, you get the weight of the precipitate. So that is how much barium sulfate produced. So this 233 is the molecular weight of the barium sulfate and 32 is the sulfur. That's why into 32 by 233. Got it? Sulfur content high is bad for health. That's why though it is giving some calorific value, we are not considering it beneficial, rather low sulfur is always considered better. Ash content, already I have discussed what is ash content, and ultimate analysis also there in the ultimate analysis also sometimes ash content is analyzed. So percentage of oxygen, finally 100 minus percentage of all the other things, you get the oxygen percentage. Okay, so I stop it here for today and go for the next chapter.